All right, example 71. It says find the integral of x sine the sine of x squared dx by using the substitution u is equal to x squared. All right, so of course, whenever we do a substitution, we're literally going to replace what we're integrating, which is a function in x, with a function of or in u. All right, so we have u is equal to x squared. Now du by dx would be equal to 2x. All right, du by dx is equal to 2x. Bring the 2x down here and bring the dx up there. We get du over 2x is equal to dx. All right, and we're doing that because we are going to have to replace dx with du. All right, now dx is equal to du over 2x. Now, some persons might be a bit concerned because they think that we're replacing all x with u, but there's an x here. Don't have to worry about it because that x is going to be cancelled by this x. All right, so don't have to worry about it. So now that I have what du is, and I know that x squared is u. Now I'm ready to do my integration. So therefore, the integral of x sine of x squared with respect to x would be equal to the integral of x. I would say don't worry about x. The sine of u du over 2x. All right. So this x here, as we said earlier, cancels this x. So now I have an integration that is entirely of a function in u. The two which is basically a half could come to the front. So this is 1/2. The integral of sine u with respect to u. All right. Now if I differentiate cos, I get minus sine. So if I integrate sine, I'm going to get minus cos. So this is equal to minus 1/2 cosine u plus c. But u is equal to x squared, so I could say that this is equal to minus 1/2 cosine of x squared plus c. All right, let's have a look at another one. That one was largely very simple. Example 72 says show that the integration of sine cube theta cos theta d theta is equal to sine 4 theta to the fourth power theta, or sine theta to the fourth power over 4 plus c. Using the substitution u is equal to sine theta. All right, so here's our substitution. U is equal to sine theta. No need to replace all theta with u. So I'll start by saying du by d theta. Differentiate sine, you're gonna get cos. So this is cos theta. So bring this down and bring the d theta up. We have du over cos theta is equal to d theta. So now we have d theta, but it's in terms of both u and cos theta. I don't have to worry about this cos theta because it's going to be cancelled by this cos theta here. All right. So let's see if we can see this in action. So now I'm ready to write up my integral in u. So the integral of sine theta is equal to u. So let's take that out. So it's the integral of u raised to the third power cosine theta times d theta by d theta, which is actually what? Du over cos theta. So the cos theta, as I said before, cancels the cos theta. So this becomes the integral of u to the third power du. Now, u to the third power becomes, when you integrate it, it becomes u to the fourth power, increase the power by 1, divide by the new power 4, plus c, which is the constant of integration. But u was equal to sine theta. So this becomes sine for theta plus c here, and this is over 4. All right, so we're asked to show that, and we did, so we can stop there. Move on to the next example. Example 73 says, show that the tangent of the integral of tan 4 theta sec square theta d theta is equal to tan 5 theta plus c, and tan 5 theta is over t. By using the substitution, t is equal to tan theta. So t is equal to tan theta. So dt by d theta is equal to, if I differentiate tan, I get sec square. So it's sec square theta. As we did before, this comes down to the bottom, that goes up to the top. We have dt over what? Sine, sorry, it's not sine, that's sec. Sec square theta is equal to d theta. And of course, I don't have to worry about the sec square theta, but it's going to be, because it's going to be cancelled by this sec square theta. And so the integral of tan 4 theta sec squared theta d theta may be written as the integral of t to the fourth power sec squared theta d theta, which is dt sec squared theta here. This cancels this, as I said previously. So this now just simply becomes the integral of t to the 4, integrating that by theta, by t. Power integral, so this becomes t to the 5, raise the power by 1, divide by the new power 5, plus c, the constant of integration. But t was tan theta, so this is tan 5 theta over 5 plus c, which is the constant of integration. And that is what we're asked to show. All right. So what example number was that? That was example 73. So we're going to stop with this example, and then in the next video, we will look at integration by substitution with limits.